In this video, we are going to learn about the unit circle. Now you'll see here I drew this very impressive circle. Now if you go online and just search unit circle, you can probably find a blank template to use for your notes in this video. But in case you want to draw it yourself, which might be more satisfying, I did just take a bowl and made a big circle, and then I cut it into 4 pieces to get these. I cut each of these sections right in half to get that middle one. And then they get these right here. I imagine this section here in thirds, and I took like the third closer to the middle. And then I drew straight edges to make everything. But I'll give you a moment to get that set up, and then we're going to talk about this. So please pause the video and take care of that. Now, back to the video. So we have the unit circle. The reason why it's called unit circle is it is a circle of radius 1, defined by x squared plus y squared equals 1. Now, all these points you're seeing along the outside all exist in this equation. You could plug in x and y, and it will always come out to be 1 no matter what. Now, the reason why we had all the videos leading up to this one is now if we imagine an angle in standard form, meaning it starts right here, 0 degrees, I can start to rotate around the circle. Now, rotating from this initial point to this terminal side straight up, that is a 90-degree rotation. Now, half of that would be 45 degrees. And then both of these angles, if you're not already catching on, will be 30 and 60 if you're thinking about our last video. And these kind of break this entire section up into thirds. Now I can continue this pattern by doing another 45 degrees from 90 degrees. That gives me 135 degrees. Another 45 would give me the 180, which makes sense. A half rotation is 180 degrees. Another 45 to this section right here gives me 225 degrees. Another 45 gives me here to 270 degrees. Another 45 gives me 315 degrees. Another 45 brings me back here for a full rotation of 360 degrees. Now all the ones in between, if you keep counting up by 30s, because that's a third of this, so 30, 30. Another 30 gives me 120 degrees. Another 30 gives me 150 degrees. Another 30, 180. Another 30, 210. Another 30 gives me 240. Another 30 gives me 270. Another 30 gives me 300 degrees. Another 30 gives me 330 degrees, followed by one final 30 to bring me back to 360 degrees. Now you can take this exercise now to convert all of these into radians, or just wait past a slight pause to see how they're all converted into radians. Now again, starting at 0 degrees, we'll have 0 radians. Now when you convert 30 degrees to radians, you'll end up with pi over 6. 45 into radians is pi over 4. 60 into radians is pi over 3. 90 into radians is pi over 2. Continuing this pattern, 120 into radians is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. And 180 degrees is pi radians. Again, 210, that's going to be 7 pi over 6. 225 will be 5 pi over 4. 240 degrees would be 4 pi over 3. 270 would be 3 pi over 2. 300 degrees will be 5 pi over 3. 315 will be 7 pi over 4. And 330 would be 11 pi over 6. Bring me back to 360 degrees, one full revolution, which is 2 pi. Now, hopefully you got all those correct, or you followed along. Now, as we start to find these exact values of trig functions, you'll start to get these like angles in mind, how to keep them in degrees and radians in your brain. There are some patterns that I use to help me remember all of these. As you can see, at the same height is the over 6, same height over 4, same height over 3, same height over 2. If there's no denominators at the middle, there's lots of little patterns you can find in there. Now let's bring in why we might want to know these angles and this unit circle. Now if I took a random point on a circle, let's call it xy on this unit circle, so still radius 1, we can actually define sine, cosine, and tangent, as well as cosecant, secant, and cotangent. Sine would be opposite over hypotenuse, so in this case it will be y over 1, which is just y. Cosine would be x adjacent over hypotenuse 1, which is just x. Tangent would be opposite over adjacent, so y over x. Cosecant would be hypotenuse over opposite, so 1 over y. But you can also use the fact that they are reciprocals to remember that. Secant would be 1 over x for opposite over adjacent. And cotangent would be x adjacent over hypotenuse y. And again, I just used this triangle right here of a random point and made one right triangle with it, with my hypotenuse being 1 because the radius of the circle would be 1. Now the reason why this is very convenient, if you look at your notes from the last lesson, if you look at the y coordinate of, say, 30 degrees, you get 1/2. Now I'm saying that sine is that y coordinate. So if you look at sine of 30 degrees from your previous lesson, it should have been 1/2. And the cosine of 30 degrees would have been square root 3 over 2. So this goes to say, if I follow this formula for the other 4 trig functions, it should give me those values as their exact number. So that's another way of remembering those. And it'll help us kind of find these multiples of these angles as we go around the unit circle. So for example, if I wanted to figure out what sine of pi over 3 was, if I knew my unit circle, I would just go to pi over 3, look at the y coordinate, and I would see that it is the square root of 3 over 2. And that's simple once you have the structure in your brain. So definitely take your time to get these patterns down. I'm going to show you a few more at the end of the video of how you can use this very effectively to evaluate trig functions at various angles. Now cosine of 5 pi over 4, I would rotate the 5 pi over 4. I see that cosine is the x coordinate, so it's just the square root of 2 over negative square root 2 over 2. So we can get negative values for our trig functions if we rotate enough. Tangent of 3 pi over 4, now that's going to be square root 2 over 2 divided by negative square root 2 over 2, because it's y over x. So I would write square root 2 over 2 divided by negative square root 2 over 2. Now that is the same thing, so they cancel out, leaving me with negative 1. So tangent of 3 pi over 4 is negative 1. Now for cosecant of 11 pi over 6, I would rotate until I found 11 pi over 6. Cosecant is 1 over y, so it'll be 1 over negative 1/2. Since that's the y coordinate of 11 pi over 6. Now you're dividing by a fraction, so you're just going to be taking that reciprocal, and that'll give me the value of negative 2. Now secant of pi over 6, that's going to be 1 over x, so it's going to be 1 over the square root 3 over 2. And again, take that reciprocal of that fraction, give me 2 over the square root of 3, and to rationalize that denominator, multiply the top and the bottom by the square root of 3, give me 2 square roots of 3 over 3. And cotangent of 7 pi over 6, rotate to that. That would be x over y. So it would be negative square root 3 over 2 over negative 1/2. These 2's in the denominators can cancel. The negative divided by negative makes a positive. Leave me with a positive square root of 3 as my answer. So it's a nice, clever way to use the unit circle to quickly evaluate these instead of drawing a triangle and trying to figure it out. Now, let's look at sine of pi. If I rotate the pi, I see that sine is going to be the y value, so that'll just be 0. Cosine of 2 pi, that's a full rotation, and the cosine here would be the x-coordinates, which would be 1. Tangent of pi over 2 would be y over x, so 1 over 0. But that is an undefined number, so we can say that tangent of pi over 2 is undefined. Cosecant of 3 pi over 2, look down here, cosecant is 1 over the y coordinate. So if here at 3 pi over 2 is -1, I get 1 over -1, giving me -1 as its value. If I did secant of 0, it's very similar to 2 pi. It also ends up with me at the same spot. And since cosine here was 1, it's going to be 1 over x, so it'll be 1 over 1, which will also make it 1 as well. And cotangent of pi over 2, I'm using the same angle I did for tangent, but in this case, since it's x over y, I can put 0 over 1, and that will give me 0. Now, these particular angles I use that are at these axes are referred to as quadrantal angles, since they're the ones that divvy up the quadrants of the graphs, like first, second, third, fourth. These are the axes that split that up. So quadrantal angles. Now lastly, I picked a few that aren't on the unit circles. You have to be a little bit more clever about how you're going to get to those answers. Since we know a full rotation is 2 pi, 17 pi over 6 doesn't appear here, but if I were to subtract a full rotation, I would end up being on the unit circle. As we saw earlier with 0 and 2 pi, being 2 pi apart, ended up in the same spot. 2 pi can also be written as 12 pi over 6. So if I subtract 12 from 17, I can get 5 pi over 6, which means that 17 pi over 6 and 5 pi over 6 end up in the same spot. And sine of 5 pi over 6 is positive 1/2. And for cosine of 390, I can use degrees. Take away 360 degrees from 390. I get cosine of 30 degrees, which leaves me with the square root of 3 over 2 at 30 degrees. Cosine of 5 pi, a full rotation down would be cosine of 3 pi, which is still not enough. Another 2 pi down gives me cosine of pi, which there, at cosine of pi, using the x-coordinate, I get -1. And then sine of 600 degrees, again, I can take away 360, a full rotation, end up with sine of 240 degrees. They should be the same value since they would end up in the same spot. And sine of 240 degrees would be negative square root 3 over 2. Now, there's lots of patterns to find. Another thing you'll find is as you reflect points, the coordinates at pi over 6 and 5 pi over 6 use the same values, just that since this point's in the second quadrant, the x value is negative. In fact, all of the over 6 radian angles have the same values, just they change depending on what the quadrant is. So there's lots of patterns you can find with this unit circle. I would definitely take some time playing with it and looking for these patterns so that you can really find a quick way to remember these values. Your goal is to do all of this in your head without the use of a unit circle, but please use it for now so you have that structure and you can build that visual help.